Hi, and welcome to my talk in the Powerful Visualizations track at this year's Notes. The track title is a perfect fit for my presentation, which focuses on creating helpful and meaningful visualizations. I hope that after my talk, many of you will realize that what they've known as graph visualization before was only the tip of the iceberg. I want to illustrate what makes graph visualizations truly awesome and powerful. Naturally, I'll provide insights on how you can create these from the data stored in your Neo4j graph databases too. We'll explore different tools, ranging from no-code and low-code to full-code solutions. But rest assured, you don't need to be a programming expert to craft exceptional visualizations. And for some of the more challenging and time-consuming tasks, we'll leverage various forms of AI to make our lives easier. But first, let me quickly introduce myself a bit in more detail. That's me, Sebastian. Now, I've been working in the field of graph visualization in my role as CTO at WiWorks for more than 20 years now. And visualization is what we focus on at WiWorks. Our tagline is the diagramming experts, and I hope that I will be able to show you why this is actually a good fit. Check us out on the internet and social media. There are multiple tools and products related to Neo4j graph visualization available from our website, and most of them are free to use. And this is our agenda for today. In the past, I had a lot of text on this slide, but I think this illustration pretty much says it all. Everyone knows these visualizations on the left, which are fine for some use cases, and sometimes there is no need to improve them. But there are many cases where the data in our graph databases can benefit massively from a more sophisticated visualization. And as we'll see, when we enhance the visualization, we can provide our users with a much better experience. The exact benefits depend on both the user and the user story, of course. After all, it's the users looking at the visualization, asking questions and looking for answers, or maybe trying to gain new insights. We'll be touching different use cases, and we'll see what makes graph visualizations more powerful so that users can benefit more from them. And of course, I'll show you how you can create those awesome visualizations too. Note that the visualization on the right is just one example for a use case that has been created with our tools. Now let me quickly give you an overview of what these tools are and how they are connected. So look at that third column. These are the main tools that I'll be showcasing in this session. They are readily available for you to use, so there's not only are they free, but they also don't require registration or installation. The third tool is a plugin for Jupyter Notebooks, so technically it does need an installation within a Jupyter environment, but nevertheless you can use it with your cloud provider, for instance on Google Collaboratory, and begin working immediately, even on your tablet or mobile devices. Some of you might have already be familiar with these tools, and in past Note conferences I presented earlier or preview versions of them in greater detail. So if you're curious, feel free to explore the Neo4j YouTube archives for more information. And specifically for the data scientists of you, check out my talk from Notes 2022 about the Jupyter Graph Visualization plugin. I won't be discussing it in today's session at all. So what's new this year? We've introduced a plethora of exciting features, and at WiWorks, we've also embraced the AI revolution, of course. We discovered impressive applications in the realm of advanced diagramming. We've incorporated large language models, integrated both natural and spoken language interfaces, all to significantly enhance the user experience. Moreover, we're leveraging the boundless creativity of ChatGPT to assist in both the design and implementation of powerful graph visualizations. I'll delve deeper into this topic later. A commonality among all these tools, and indeed any graph visualization you'll see in this presentation, is that they have been created with the help of our programming library YFiles, which is the software development kit that we have been building all along at WiWorks. All the tools that we'll be looking at run on the web platform, and Neo4j has a connector for communicating with Neo4j databases on that platform too, of course. If you want to try out what I will show you today with your own data, in order to get started, everything you need is credentials for your database, and read access will actually suffice. With the Neo4j connector, our apps can connect directly from the running browser application to the database. This means your data never leaves your systems or touches our servers. You can run these tools offline, disconnected from the internet or from behind a firewall if you wish to, and you don't need to expose your database in any manner. I encourage you to give it a shot. Okay, so why should you consider yet another set of graph visualization tools? What sets these visualizations apart as powerful and worthy of your attention? Why choose our tools or even our commercial software library over other available options? The answer is simple. Our tools enable you to accomplish tasks that most other tools cannot. With our diagramming library Y-Files, you can craft powerful visualizations that are precisely tailored to your specific use cases. Now let me present some examples of what we believe defines a truly powerful graph visualization. Let's begin by examining the visualization of various elements in a diagram. Nodes are not restricted to being represented by just simple geometric shapes, and relationships in a diagram aren't limited to straight lines. Often, there's more information associated with these elements than what a labeled circle can actually convey. So why not display that information directly within the diagram? You can use level of detail rendering or show more details as a user zooms in on the diagram and simplify this visualization when zoomed out. You can present the essential information directly inside the node or along the connections. To facilitate instant recognition, utilize features like gauges, icons, progress bars, images, and even embedded charts or interactive UI components. And if there's additional helpful data outside of the database available, you can augment the visualization with information from other sources too. You might even integrate live data in your visualization. You can apply many of these visualization techniques not just to nodes, but also to edges and even labels. Often, I notice that many don't realize this next crucial point when they're about to visualize elements from their graph database. There's absolutely no requirement to depict every node as a box or circle in your diagram, nor every relationship as a line connecting these elements. In reality, the database schema might have already been optimized to work seamlessly with its original data sources, or it might have been custom designed to support and optimize particular database queries. Consequently, the implicit schema in your database might not be the most suitable one for visualization. Moreover, remember that efficient visualization tools can do much more than merely draw boxes and lines. You should leverage these additional capabilities to enhance the visualization's accessibility. Consider the following. Some relationships are better left unpresented as lines. For hierarchies, expressed as relationships or node properties in the database, consider techniques like nesting nodes recursively. Here, the hierarchy gets visualized through containment, significantly reducing clutter from the diagram. Depending on the use case, sometimes it can be more intuitive to display shared property values as connected standalone nodes. There are often instances when showcasing transitive relationships, which aren't explicitly in the database, provide the insights users seek. And again, they enable us to reduce the amount of unnecessary noise in the visualization. At times, it's beneficial to group multiple relationships into one or a few edge bundles, enhancing the diagram's readability. So, embrace the idea that visualization doesn't necessitate a direct one-to-one mapping from database elements to visual elements. Remember, altering the storage or the implicit schema in your database is not mandatory. These transformations can easily be accomplished at the visualization layer. Also, please don't assume that merely placing nodes close to their neighbors on the screen is sufficient. The placement of nodes and the routing of connecting lines can encode a wealth of meaning. If that meaning is important for your use case, you should present it clearly. When your items belong to different categories and those distinctions matter to your users, factor that information into the layout and put items of the same category closer together, or even apply an extra layout to them. When there's a flow in your data, emphasize this flow across the edges using directed layouts. If your data contains hierarchies, present them in the manner users would typically expect them, often top to bottom, for example. Move start nodes and end nodes to the respective sides in the layout to help the user quickly see entry and exit points. With advanced automatic graph layouts, you can specify many different constraints that assist in highlighting details, clusters, subgroups, outliers, dependencies, and so on. And a sophisticated edge routing allows users to see the connections, even if there are many of them. Use bundling for the edges if there are too many edges, but make sure the user can identify those connections when they are interested in. You can even consider utilizing multiple layout algorithms with varying configurations to emphasize different facets of the data that the user might be interested in, and then animate smoothly from one layout to another, allowing the user to keep their mental map of the data. Next topic. So what's behind your graph visualization in the background? Is it an empty canvas? The background doesn't need to remain blank. For instance, when relevant, place your nodes within a table with defined rows and columns. Alternatively, organize them into parallel swim lanes to convey useful categorical information. This can be more effective than merely representing that information as a textual property or adding yet another node and connection. Even scalar data can be effectively visualized using things like heat maps in the background, for example. You may also render the outcomes of graph algorithm runs into your background visualization. You can use centrality measures, shorted path analysis, clustering results, dependency analysis results, and embed that information in the drawing. Also, things like grouping information, different types, or category details may be seamlessly incorporated into the backdrop. And lastly, if geodata is important to your audience, you can of course position nodes on a geographic map too. Therefore, think twice before leaving your background empty in the visualization. Okay, now let's discuss the most important aspect. While static visualizations have their merits, the complexity we often see in graph database use cases necessitates the addition of interactivity to enhance the user experience. Proper interactivity not only makes for a more powerful visualization, but also significantly enhances its utility. Certain interactions are fundamental to aiding users in data exploration, searching for elements, selecting them, displaying details, and providing tooltips. However, interactivity's potential extends beyond these basics. It can be harnessed to let the user interactively explore features of the network. For instance, to identify bottlenecks in supply chain networks, conduct root cause analysis, or interactively view upstream and downstream elements in a larger flow. Techniques like fading out, filtering, and drill down are invaluable when focusing on a graph subset. And we haven't touched upon the possibilities when you start to let the user edit the graph. While often graph databases are explored visually, of course, you can also use graphical editing capabilities to play back changes and populate your graph database. Many of these methods assist in reducing complexity and keep the user from having to untangle the hairball. For large graphs with interactivity, it's possible to drill down and simultaneously employ multiple views of the same data. For example, we can add separate neighborhood views, detailed views of the graph, or of the user's currently selected elements. And last but not least, make your visualizations easily accessible and, when helpful, deeply integrated into the workflow of your users. When a particular user story frequently arises, it's worth investing in a highly interactive and specialized user interface, tailored to address the specific needs of your users most effectively. Don't force your users to toggle between apps when you can consolidate the information and functionality within your visualization. Minimize unnecessary clicks and additional steps. Allow users to perform actions or initiate other apps directly from the visualization itself. When applicable, instead of developing a new application, consider integrating the visualization into existing apps dashboards, or even into notebooks. Align with the corporate design and interaction protocols to ensure your users feel immediately at home and confident. But isn't this a lot of work? Creating helpful visualizations like those in the previous slides certainly requires attention to detail, plus ideally a good knowledge of the business domain and the various user stories. We need tools that help us build these custom-made experiences. Let me show you what Wireworks provides and how we integrated AI and generative technologies to assist developers and users with their tasks. We start by looking at our Data Explorer for Neo4j. At its core, it's a visual database exploration tool, not unsimilar to others that you may have seen today. Except, like I said, that it requires no installation and works from your browser, so it can safely connect to your database even from within your intranets. Other than that, it also offers some visualization superpowers. Since this is an exploration tool, the most obvious thing to look at is the interactivity. I won't go very much into the details here, but I will show you how to interactively drill down through your data with the assistance of an AI. Now, this is the Data Explorer interface, just loaded from our website. For this example, I connected to the movies database example that some of you probably already know. The movie database example has a very simple schema that consists of the persons and how they are related to movies. Persons can be actors, directors, and so on. And in the schema, we can also see that there are some properties associated with the elements. So let's start exploring. I could use regular search dialogues, but this is the first place where we'll be using the power of AI. Here, I can even use my microphone to enter my database query using natural language, spoken language. The Data Explorer will create the query for us and execute it. I'm searching here for the actor Keanu Reeves. Data Explorer listens to me speak, checks the schema, creates the query, and executes it. And we found Keanu. But we can do also more complex queries that involve our current browsing context, in this case, the selected elements in our visualization. I want to load movies that were released in the 1990s where the selected actor appeared in. This works. Now I want to load all the movies that have the word Matrix in their title. And here we go. This could all be done manually too, of course, but this is much more convenient this way, I'm sure you will agree. Take this query, for example. Load actors that appear in all the selected movies. Would you know how to write the query? Writing Cypher queries for use cases like this may not be extremely difficult, but it can become more difficult quickly. Let's see how ChatGPT is used under the hood. Let's see how ChatGPT, which is used under the hood, can deal with a more complicated and a powerful query. For this one, we'll look at graph transformation and projections. For example, when I'm interested more in which actor co-acted with another actor, I might not want to see the intermediate hop, the movie where they co-acted in. Remember that in the database, there are only connections between actors and movies, but there's no direct connection between co-acting actors. So let's see how the Data Explorer can help here. For this, we use the transitive edges feature of the Data Explorer. First, let's get rid of the older results. And now, without changing the database, back in the schema view, we can simply declare a transitive multi-hop relationship from actors via movies and back to actors. And thus we define a new co-acted in virtual relationship. Data Explorer now understands this new type of relationship that's implicitly available with my graph. In my diagram, I select Keanu, and I can now directly explore the new transitive relationship via the regular UI. And in this case, this gives me a lot of results. Again, instead we can ask the AI to create a more complex query for us with a nice filter applied. I want to find the co-actors of Keanu who appeared in the Matrix movies, but without showing the Matrix movies. This time I go via the menu to let ChatGPT create the query for me. Unfortunately, when I tested this, this time it made a slight mistake and messed up some variable names. However, in this UI, I can fix the query and execute it. So there's just this M over here wrong. And once I fix the query, I can execute it and then load the results into my diagram. So, and to prove to you that this works, as a last test for AI's Cypher capabilities, let's again find those movies that my co-actors co-appeared in, but only those where at least 3 of them appeared. This is a rather complex query that uses the context of our diagram. And this time, let's see how ChatGPT manages to do this. I enter the query, and then let the AI create the query. And this time it actually works. So as you've seen, you can use this tool to author and test your Cypher queries too. They can be copied to your own notebooks and programs and so on. And we'll use this later on too. So now that we've seen how to interact with our database in the Data Explorer, let's take a look at the visualization of the items. We'll try to create different visualizations for our nodes, and we'll see how the AI can help us with this task. For the styling, let's look at a more complex example. This is a database that contains fake patient data. It has lots of information about patients, what encounters they had at what organization, and all kinds of attributes for these encounters. When I explore the data set for the first time, you will see that there are very basic visualizations used. We only get to see basically the labels and some type titles. But there's more information available with all these elements, like we can see here. So I can go to the styling panel and add a template for the specific type of label, in this case, the patient. So I'm adding a label, specifying a template, and I specify the label for which to create a nicer template. And when I click this button, an editor opens up, and I can drag and drop the properties onto the template. Like just in this case, we can use the address, for example, and we can also take first, which probably is first name. And we can also add things like, I don't know, for example, the gender, and even add the birth date, which we see is actually a nested property. So there's actually 3 properties that we have to put into the template to get a nice formatting. Now, this is tedious. This is super flexible, but it's quite tedious. You can do all kinds of things like add prefixes, change the way the values are displayed, and add additional labels, additional static texts, change the colors, bind them to values, even add shapes to the visualization. They could be data bound too, or icons. That's all worth it if you spend a lot of time in it, because you get a much better visualization. But it's quite tedious to do, and sometimes we need to do this quickly for many different templates. Generative AI to the rescue. The AI template generator, which we have in this button, will go and inspect the names and the types of the properties, determine which ones are important and how the information should be presented. It will automatically come up with formatting, proper names, and even icons to make this more accessible. Once we use this template, you will agree that this looks much nicer. We can do this for the other items as well. There's even a shortcut that will generate the template directly for me. I just select the encounter and then hit the shortcut button. It will generate the template, come up with a nice visual presentation, and then we're done. And I prepared more templates and saved them so that I can share them with my colleagues, for example, because this is all running locally on my system. And of course, this can be loaded back into my view to finally apply a nicer layout. And this is my much improved visualization. So far, so good. We haven't covered yet rendering canvas backgrounds and showing additional information. And with regards to interactivity, there's actually more than what the Data Explorer has to offer. So let's check this out. Okay, here we have another set of patients along with encounters and organizations. And if we look at the data, note that there's geolocation stored with each of the patients. So we can go back to the schema view, select the item for a patient, and in the properties list, we can mark the location as geodata for use in a map view. The same works in organizations too in this data example. And back in the Explorer view, we can now start the map view. This loads a map and places all the nodes onto the map at their geolocations, except for the encounter nodes for which there's no map location available. But we can use the lens functionality to reveal this additional information dynamically. This helps us unclutter those areas where the elements overlap due to their geographic closeness, and shows the ones for which there's no geographic information available. Data Explorer still is a rather generic tool, and there are lots of advanced visualization use cases that are not supported by the Data Explorer yet. We haven't covered more sophisticated backgrounds, custom-tailored interactivity, and of course, no integrations. Luckily, there's a convenient escape hatch for software developers, and that is the so-called app generator. The app generator is a low-code tool for scaffolding source code of visualization apps and reusable components. So let's use it. All I need to do is use the export to app generator feature. This will take the configuration I created with the help of the AI and open it in the app generator. I'm not going to explain in detail how this works in this presentation. I'll just speed run you through until we have our first application. We see that there's a place where the query is specified, and all the other configuration items basically contain the styling information that the AI created for us. So now I'm just hitting the play button and execute a preview of my app. Now I can hit the export button to create a source code bundle. Here, I'm specifying that I would like to create a React app with React components using TypeScript, and along with some application features that I want to use in my resulting visualization. So we're going to use the context menu, we want to see an overview, interactive editing, tooltips, and so on. So then I hit the button and the zip file will be downloaded. And after extracting it, I can open the project in my IDE. And all that's left to do is just two more simple steps. I need to, as with every web project, need to install the dependencies using npm install. And then once it's done, start my development server, which is a Vite.js server in this case. Then open the app. And here we have our graph, dynamically fetched from the database using our AI-generated templates. And I could easily embed and reuse custom Cypher queries created with the help of the AI too. As a software developer, you now have a running visualization app or a component that you can add to your programs. Chances are, though, that I showed you some examples for powerful graph visualizations that you would like to use in your visualization too, but neither the app generator supports them or they aren't available in the Data Explorer. But this doesn't mean you cannot have them. You can reuse the source code of the hundreds of demos that come with our library. Let me quickly show you how I added the Heatmap feature for the generated app with just one line of code. So I want to add the functionality from one of the Y-Files demos to my app. I go over to my package, which comes with all of these demos. I search for the Heatmap features, which is part of the process mapping demo, which you've seen before. So let's check the demo. This is the one, and I want to have that Heatmap in my graph visualization. So I locate the file in the demo that encapsulates that feature, and all I'm doing is copying it over to my application. That file has a single entry point exported, and that is a function called add heatmap. So there it is. So from my application, I first locate where there is the Y-Files graph component API. In this case, it's wrapped in some React component. There it is. I can call this function, and I need to tell it what values to use for the heat map. And in this case, I'm using the Neo4j properties object, which is attached to all the nodes in my visualization. And this one contains the claim cost from the database as a property. I'm normalizing it because these values are actually quite large, and they should be in a lower value range. So hitting save, and my application already adopted the change and shows the heat map values. Isn't it great? And of course, there are features that are more complicated to add and to configure, but we really try hard to make functionality available as easy as this. I hope this gives you some inspirations for your next visualization project, and that I was able to show you how AI can help with that. We've seen the benefits of using tailored designs for our nodes and relationships, how we can use the power of sophisticated layouts to encode information into our diagrams, how interactivity can make a difference and turn our visualization into a useful and powerful tool, and how integrating the diagram or the graph visualization into our users' workflows can boost their productivity. By now, we can let the AI do some of the design work so that we can see the data in meaningful ways more quickly. Large language models can help us navigate our graph database and create queries both for use in the Data Explorer as well as in our custom visualizations. At Yworks, we're continuously working on teaching AIs more tricks. For example, to do more of the integration work, choose the right layout, and so on. So do stay tuned. But even today, I'm eager to see what you will build with our tools and your data. Create awesomely powerful visualizations from your graphs. I just showed you how. So with this, happy diagramming with the Yworks tools and the software libraries, and of course with Neo4j. Thank you.